Hello, people. So let's continue where we left off last time. Last time I coded this fake the ballistic curve for the frog so that we have a. Oh, hold on a moment. I believe I need to disable Windows Ink so that I can zoom. Yes. Um. So we now have an animation. Well, a motion curve for the frog that we can use to implement some um, procedural animation instead of having it depend on the animation that's defined in the jumping frog here. This one. So I thought I'll try and take you along on that little journey and hope to God that I don't make the same mistakes I did last time when everything went quite apeshit, so to say. So, let's see what we have now. We now have a. Well, we all defined it in the jump and frog thing here, so I guess we should make the jumping frog script also responsible for moving the jumping frog um, along the curve, because we have defined it. Ideally, I would just enable this like I did last time and have some script on here take care of the animation, but since all my code is in the jumping frog script right now, I think it would be better if we try at least to do it in this bit here. So we already have an is in action, which is when the frog is jumping. If has entered water, this is just registering if we need to display or spawn the splash. This is where we can reset the frog once it has reached its endpoint, and I assume we can actually replace this in a bit when we have when we can measure that the complete animation has how do you say, has finished, because now we're driving it fully with the scripts. So if we're in action, what do we need really? Let's see. This measure duration is now in the onDraw gizmos. We need to pick that out of here and also measure the duration if the target position has changed from the last things we checked. So let's just pick this up here. These lines can go here, I'm quite sure. And let's see, let's move these few also up somewhere where they're more logical, like here. Okay. So this only comes into effect if we're in action. That might not be the best thing. Let's also... No, we'll leave this in a function so we can still use the onDraw gizmos referring to the same function. This can go now. Okay. So what we did here to draw the gizmo line is kind of like what we will be doing here, but then in time. So we will need a float jump clock, or shall we make it a phase? I like using phases because it keeps things simple. What we're gonna do, we're gonna just add to jump phase with a timer dot delta time times no divided by the duration, so that it takes longer. If the duration is bigger, then we'll calculate the actual position of the jumping frog. Maybe for now, let's just do jump. Do we have a... Yes, we have a jumping frog. Oh, action object. We should call it an action object. Action object dot position equals the ballistic curve is now dependent on time. Let's make a vector 3 ballistic point normalized float phase, and that's just ballistic point phase times duration. Right? Just for now, and because I don't like how this reads right now, I'm calling this jump position get jump position, and this will be get jump position normalized. There we go. Let's get jump position normalized jump phase. This should be transform. So now this should already work. But now, obviously, it only works during play mode. I'm having a sip of coffee. How do we test this? I can obviously just go into... let me see, what's the trigger setup again? It triggers with this box here. If I let this box drop from here, we should actually trigger the animation. And it will probably not end right now, because the end calculation is not correct. Okay, I don't think that worked, but I'm not sure, because we couldn't see it, because the screen went black. Also, we haven't put it neatly at the top. Let's see. Let's set it up so that we can actually see what happens here. I'm gonna fill in a nice big drag value to see if we can catch the jumping in the act. Play. I didn't see anything happening. Frog is still here. Also, there's still an animator on this frog. We should turn that off. Let me think what happens here. This is, yeah, engage jump. It should work, right? Once more. Not exactly. What happens if we lift the cube and let it drop again? There we go. Excellent. It doesn't reset. Let's see. So the jump phase here can go up. This is just a clock, really. If we're engaging the jump here, action object set active is in action, has underwater, splash effect set active false. Jump phase can be 0. Yes. We can keep this here, but if we are jump phasing, if jump phase is bigger or, well, let's just do bigger than 1, then we reset. And with that, we can lose this here. So the disappear surface is actually something that we don't need anymore. So let's try that again. Are we recording correctly? Yes, seems good. I lift the cube. Oop, there we go. Excellent. It's a bit slow. So let's see, the frog is now horizontal speed. Let's make that 2. And you know what? I'm gonna restrict this one in X and Z and restrict the rotation so we have a more reliable control to trigger the frog here. Cool. That's kind of quick. Let's see, 1 maybe? Cube, come on. Seems still a bit fast. 65 then. How come it's still so incredibly quick? Because I had it at 0.5 and that seemed too slow. How does this happen? Oh, I know what happens. Yeah. The duration here only gets a reset if this differs. We should make sure that we simply measure the duration when we engage the jump every time. Yes, that should be good. And then this can go. So now the duration will be measured every time we engage a jump. I will leave this in here because we're using the duration calculations for the drawing of the curve. And the curve should actually only update, not necessarily if the duration changes, but only if the jump target changes. So let's see. I will lock you. 2 was too much. Lock you. I can't lock you during compilation, it seems. Lock me, please. There we go. So let's try 1 meter a second. Okay. Seems okay-ish. I don't really like the downward slope that much. Maybe if it goes like this. No, that's way too quick, I guess. .8 is a bit slow, it seems. Maybe 1 was just good enough. And maybe we just need to change the curve a little, because it might be that it is a bit weird. Maybe you just wanna just experimenting with the actual motion here. Maybe you want a more of like a circle, a dome curve here. Let's see what this does. Seems nicer. Curve doesn't seem very good, but well, the most important thing seems to be the downward slope. Feels like it's forever increasing in speed. The upward slope we believe. There we go. Okay. Cool. Me likey. There you go. Now, simple things. Obviously the frog needs to rotate a little, and that's not that difficult in this case. What we can do is, where are we? Yes, jump phase is added. We will give it a rotation, and since let's see, we can probably just do a simple look at and have this follow the curve, the z-axis. So let's see, action object dot rotation dot transform rotate. I like to do obviously you could do a look at here if you, well, this works as well, but with a look at, let's see if it shows it, you need to have a target object, and with the rotation look at, so rotation, or the quaternion look at, quaternion dot look, what's it called again, look rotation, you can have a forward vector, which I like a lot more, and especially in this case, because now we can say to the frog that you have to look along the curve. So we here get the jump. Wait a moment. Let me reformat this. We need to have a direction between where we are and the next step of the curve. So like so, more or less. So we know where we are because we just set our position, but we also know where we're going because we pre-calculated the curve. Get the jump position normalized, and then let's just do jump phase at plus 0.01, just a tiny step forward should be enough. That should be relative to the current position, transform dot position. That's one, and then we just use the world up vector to keep it upright. This should already work. Okay, gimme, please. I need to raise the cube. I'm not sure if we're doing it correctly now. I just paused by the key combo. Let's step along. I'm not sure I like where this is going, really. Let's see. So it's actually not rotating correctly. Oh, I'm using transform position. I should obviously use action object dot transform. Oh, sorry. It can just go like this. I was using it's rotating. The forward factor it takes is from the source object, so this to the next point in the curve, so that didn't work. But this should actually work perfectly. Let's hope so. Okay. Go on. I realize I can enlarge the thing here. There we go. That looks better. Let's see how this looks. Yes, I like this. I like this a lot. Yep. There's your froggy. Now, what I noticed is that sometimes if you keep triggering it, it resets anyway. And that's because this gets cold, and in the last version we just were already running an animation and it just simply kept running. So that would not lead to the resetting that happens here. But because we now set the phase to 0 here, and well, this is not important, but we're setting the phase to 0, we only want to run this whole thing when we're not actually jumping. So let's just cancel that out. If is in action, we simply return. And then we can only trigger when we're actually sitting there being a frog. Yes, let's try this out. Right. Yep, it just triggers now. That is to say, if we're already in motion, we can't trigger anymore. The fact that I'm triggering it now with a actual trigger and cube combo is not important. At a certain time, I want to trigger this when you come closer as a player. So it only jumps when your head moves in close, for example. I'm not sure yet what I want to do. Oh, is this too loud? I don't know. And in that case as well, you don't want to re-trigger and re-trigger this every time you get closer. So this is actually good and working correctly. That last bit here is just a display thing, I think. Or does the frog? Let's let's see what happens there. The frog is actually doing something silly there. Chup, 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 chup. There it comes. Whee! Just frame stepping to the last bit of the curve here and seeing what happens to the little beast. Here it reaches the water, splashes go off. Let me select it. And here it reaches the last bit of the curve and it just disappears. Great, so this is just a display thing. Good. So I think that's it for the next step. Let me know if you have any questions or remarks or wondering where I'm going. And I'll see you in a next video. Wait a moment. There's something we haven't tested yet, and that's what happens if we move the target around. So this is a good jump, but what happens if that jump target is, say, over here, for example? Yoop. Okay, and I think that's okay. What happens if it's over here? Excellent. It takes longer. What happens if it's... let's see. Let's move it over here. And... it's a flying frog. Excellent. Love it. Eee. That's a powerful frog, man. There he comes. Cool. Yeah, that looks a bit silly, I think, but actually it's moving way too quickly. It should, in this case, probably have a much higher curve, but since we're, let's see, since I'm thinking of making this target go along like this range here, I think we should be okay, really. So like this, and raise the cube again. Should be good. Another thing I really want to try is what happens if the frog is on another level, other spot. This will trigger it. I'm not sure what I'm putting it now, but the jump target, well, it could be anywhere really. Let's see what happens if the jump target's over here. Neato. I'm noticing one thing. I don't know if it's a bad thing really, but I think it would be a good thing, and I guess I will continue the video like this, just to add that little extra bit, that the frog is actually already pointing in the direction of its jump targets. Because I don't think, getting into the mind of the little frog here, that it would, if it's here and it feels threatened, that it would then jump that way. So let's imagine it's already pointing in that direction. So we should do that, I guess, in the reset feed. And for that to work, we will need, assuming that the frog is flat, we will need the direction to the jump target dot position minus where we are right now. transform dot position, and we will want to have the scale dot scale of that, and new factor 3 1 goes 0.1, so we're only pointing horizontally, and that is for us now the new direction. But the problem is, as soon as we rotate the frog, we're also displacing the target. So if we're resetting, we will have to remember for now factor 3 jump pos equals jump target dot position. Bear with me here. Jump target dot position, and we can, well, let's just use it in here just because it's shorter. And after we've transform dot rotation, same trick as before, is quaternion dot look rotation, right? Look rotation, and we will use this as the first parameter and use vector 3 dot up. I hope you don't mind me formatting my code like this. This is how I like to work. Get everything as much in one function as possible. It looks a bit messy maybe, but I like it like this. So now after we've set the new rotation, we will want to remove the jump target dot position back to where it was. There. So it stays at the same place in global space, even when we are rotating the actual frog. So at reset, we will rotate towards the actual jump target, and yeah, that should work. And we'll have to check if this actually works when we're spawning them, because we're running reset here on awake, but we may want to also run it after we've set up the spawned frogs with their jump positions. But that's just a simple question of calling on reset. We'll have to remember that. This should already work as it is. You know what? I'm gonna give this thing, oh, sorry, the jump target here, just because it's nicer to play around. A mesh filter. Let's have a cube in there and a mesh renderer and just a default material, and let's scale it way down so that I have something to select in my viewports. Okay, so let's see. What happens? So the target is over there. If it should turn maybe a bit after it resets. So I'm gonna have it jump over here now. And then after it has jumped, yes, look at it. It's already pointing in the right direction. Cool. And if it's jumping over there, And as you can see, the target stays at the same location. So we're all good. Oh, I think it gets stuck. Yup. Kafloop. Cool. That works. Well, I thought I should add that to the explanation. So this is my final goodbye. Hope this was worth it. See you in the next one. Cheers.